Okay, let's continue looking at simultaneous linear equations and how we solve them. Let's have a look at the substitution method. Now, this is preferred really to the graphical methods that we've looked at so far. They take a lot longer to be able to solve because you have to find points for x and y for multiple points on each line, and there's more than one line. So these methods, the substitution method and the next one that we'll be looking at, are much quicker. Okay, so let's get into the substitution method. I've got my two linear equations. Y is equal to 2x minus 1, that's my first equation, and 3x plus 4y equals 29. That's my second equation. So what I'm going to do is I'm going to do some substituting. You see, because my first equation has a value for y, I know that y is actually equal to 2x minus 1. So because this y is all by itself on the left-hand side, I know that the right-hand side is equal to what y is. So what I'm going to do is I'm going to take this part of my first equation and I'm going to put it into the second equation where I know that there is a y. Okay, so let's have a look at how we'd actually set that out. We would write, I'm going to substitute 2x minus 1 into 2, my second equation. When I rewrite it, it will look like that. So it was 4y before, but now it's 4 multiplied by what my value of y is, which I know was 2x minus 1. And it still is all the same. Everything else is the same. Okay, so let's work this through. I will need to use the distributive law and multiply out the brackets, which just becomes 8x minus 4. I can then find my like terms, 3x and 8x, and add them together, and that will equal 11x. I then will add 4 to both sides to get rid of the minus 4 on the left-hand side. That will give me 11x is equal to 33. I'll divide both by 11, and I will get x is equal to 3. Now I have a value, a numerical value, for my x value. So I'll take this x value and I will plug that back into my first equation. So I'll rewrite my first equation using, instead of x, my value for x, which is 3. And I'll just work that through and I'll see that my y is equal to 5. So I write down that that's my solution. My solution is x is equal to 3, y is equal to 5. The coordinate points are just right here, 3, 5. As with all of these linear equations, we need to do a check. Now, because we have already used the first equation to get my y value, we should check using the second equation. So I'm going to take my values of x and y and I'm going to plug them back into the second equation. So I look at the left-hand side of the second equation. I know it was 3x plus 4y. I put in my values for x and y, and I will work that out to be 29. And I know that the right-hand side was 29 anyway. So I know that because the left-hand side and the right-hand side are equal, the solution is correct. And that is it. That's how you do substitution method. It's much quicker and easier than doing the graphical solutions because you don't have to draw graphs or think about more points than just that one point. As a word of warning, let me just give you another example really quickly. Sometimes you'll have the initial setup where you have the value of y being equal to two things. Okay, so here my value of y is here and my value of y is this. Well, when I substitute 1 into 2, I'm going to end up with values of x on both sides of my equation. That's not a problem. We just need to get that x together. So really quickly, I'm not going to go through this whole solution, but just this part, I shift my minus 3x over this side by adding 3x to both sides, and I'll get 8x. I can then shift my minus 8. I'll add 8 to both sides, and then I'll just divide by 8, and I will end up with my final solution with x is equal to 3. Then you would take that x is equal to 3, substitute your value of x back into your first equation, work out a value for y, and then you do your check where you substitute your values for x and y into your second equation to make sure that it all works out. Okay, so that is how you do simultaneous linear equations using the substitution method.